Today's lesson is section 10.2, areas of trapezoids, rhombi, and kites. Let's get started. In lesson 6.6, you learned that a trapezoid is a quadrilateral with exactly one pair of parallel sides. These parallel sides are called bases. The height of a trapezoid is the perpendicular distance between its bases. See a couple of the figures here. The area of a parallelogram is the product of the height and the sum of the bases, B1 and B2. Key concept, the area of a trapezoid. The area of a trapezoid is 1/2 the product of the height and the sum of its bases, 1/2 times the height times B1 plus B2. Example 1, find the area of each trapezoid. So we've got the formula already written out for us. Here we go. So this first one, we have a height of 11. We have our two bases of 15 and 7.5. So here we go. So you got 1/2 times the height, which is 11, times the sum of the two bases, 15 and 7.5. Uh, 1/2 times 11 is 5.5. It's 5.5. And 15 plus 7.5 is 22.5. So the area of trapezoid, letter A, is 123.75 square inches. Letter B, find the area of the trapezoid. 31, 16, and the height is 5. 1/2 times the height, in this case it's 5, times the sum of 31 and 16. Uh, 1/2 times 5 in this case is 2.5. And 31 plus 16 is 47. .5 times 47 is 117.5 square meters. And that is letter B. Moving on to letter C, 7.2, areas of trapezoids. Here you go, you got a 12, a 24, and the height is 28. So 1/2 times the height, which is 28, times the sum, B1 plus B2, which is 12 and 24. One-half times 28 is 14, and 12 plus 24 is 36. 36. And your letter C is 504 square yards. 504 square yards. Area of a trapezoid. Last one on page 1, letter D. We have ourselves 1/2. You know, the height of this trapezoid is 38.25. So 38.25. B1 is 20.5, 20.5. And B2 is the sum of 20.5 plus another 10, which is 30.5. We got this little 5 here. We got this little 5 here. And in between, you got 20.5. Okay, by doing this calculator work, you have 975.4 square feet. And that's page 1 of 10.2, areas of trapezoids. Let's move on to page 2. Example 2 is a Miguel designing a deck. It's deck building season with the summer coming on. Miguel designed a deck shaped like a trapezoid shown below. Find the area of the deck. Okay, so here we go. So we've got ourselves, let's just kind of draw our height in here. Okay, so this happens to be 5, and this is 4. And by the Pythagorean triple, 3, 4, 5, surveyor's triangle, you know what this is 3. Okay, so if this is 3, you know that this is 6. Okay, again, so it's 9 all the way across. 4 is the height. Hypotenuse is 5. That puts this little leg here of 3. Okay, so the area of this deck will be 1/2 times the height, which is 4, times the sum of the 9 and the 6. Okay, so you got 9 plus the 6. Okay. So you got your 6 here. This happens to be 6. That was 3. That was 4. Okay, so we got to find that 3 first to get to tell us that was 6. Okay, so 1/2 times 4 is 2. 9 plus 6 is 15. And the area of that deck is 30 square feet for Miguel. And that's example 2. Recall from lesson 6.5 and 6.6 that a rhombus is a parallelogram with all 4 sides congruent. And a kite is a quadrilateral with exactly 2 pairs of consecutive sides. Okay, so we have ourselves a kite here, which has got the consecutive sides. Boom, boom. And we got the rhombus, which is a parallelogram with all 4 sides congruent. So the areas of a rhombi and kites are related to the lengths of the diagonals. Let's get to that key concept. We're almost done for today. Area of a rhombus or a kite. The area of a rhombus or a kite is 1/2 the product of the length of its diagonals D1 and D2. So you've got your kite here, or rhombus, I should say. This is more of the kite picture. So you have your diagonals D1 and you got your diagonal D2. So you take 1/2 times the product of your D1 times D2. Likewise with the kite. Let's do some examples for this. Here's a kite. So the area of this will be equal to 1/2 times the D1 times D2. Okay, so we're going to have that all the way around here. And let's do this. Got it for that problem. And we got it for this problem. And we have it for this problem. Not sure if that saved me any time, but whatever. Okay, let's do letter A. So we have 1/2. Let me flip my pen back on. So I got 1/2 times D1, which is 7, and D2, which is 12. And that calculator work gets you 42 square feet. Letter B, 1/2 times D1, which is 14, because this side's 7. If that's 7, this is 7. So D1 is 14, and D2 happens to be 18. So that calculator work gets you 126 for that kite, 126 square inches. Letter C, 1/2 times D1 times D2. Get your 20 and 20, 56, and this one happens to be 26. So that is 1/2 times the D1, which is 40, 20 plus 20. And D2 is 56 and 26, which is 82. And that calculator work is 1,640 square inches. And letter D, 1/2 times D1 times D2. So we have ourselves here, again, this has got to be equal here and here, 2. So this is 2 and 2. This is 5 and 5 and 5 is 10. So 2 plus 2 is 4, and 10 and 1/2. 20 square centimeters. So in a rhombus, the diagonals bisect each other. Okay, so that's why we have to put 5 here. Okay, so in a rhombus, the diagonals bisect each other. Okay, almost done for today. Let's go to the next page. You can use algebra to solve for unknown measures in trapezoids, rhombi, and kites. Trapezoid QRST has an area of 210 square yards. Find the height of QRST. All right, so we're going to try to find this height right here. So the area of the trapezoid is 1/2 times the height times the sum of B1 plus B2. So we have the area of 210 according to the problem. So if the area is 210 and we have 1/2 times the height, we don't know what the height is, but we do know what B1 and B2 is, 20 plus 50. 20 plus a 50. All right, so let's do some algebra here. 210. I'm going to back up here. Let's multiply and get rid of this half. It's always good to get rid of those fractions by looking at the reciprocal of 1/2, which is 2. So we're going to multiply each side by 2 in order to eliminate this. So we're going to take out this 2 on this side, and we're going to multiply this side also by 2. Okay? And what that does is it kind of cleans up the problem here. 420 is the left side, and that's equal to the height now, because this cancels the height times 70. Okay? All right, so if you're going to offset this multiplication, you're going to divide by the 70. Think of inverse now. 420 divided by 70 is 6. So the height of the trapezoid is 6 yards. 70 cancels, and that would be the height of QRST. Okay, we have 3 more examples. Let's go to example 5 now. Here's another one, trapezoid, or it's a kite. So the area of the kite is equal to 1/2 times the diagonal 1 times diagonal 2. Okay, so we have x millimeters. We know the area is 247.5. And we know that one of the diagonals is just 22.5. So 1/2 times 22.5, and that's going to be times d2, which is x. Okay? Now, in order to get rid of this half again, let's multiply both sides of this equation by the reciprocal, which is 2. Okay, the reciprocal to clean up this problem here, get it by 2. And then we can move forward. This becomes 495 on the left. And then on the right, we have 22.5 times x. And lastly, to offset this inverse of multiplying by 22.5, you divide by 22.5 on this side and on this side. And your final answer for the diagonal x is 22 millimeters. So keep on the lookout for those algebra questions on unknown measures of trapezoids, rhombi, and kites. 2 more problems. Here we go. Example 6. A trapezoid has a height of 8 meters. So let's put a trapezoid in here, 8. A base length of 10. Okay, this is 10. And an area of 72. So we know that the 72 is the area. Okay, so if the area is 1/2, I suppose I could finish drawing my kite or trapezoid in here. Okay, so there's the 8 is the height, and one of the base is 10. We're looking for that top base of x. All right, so 72 is equal to 1/2 times the height, so that's 8. We were told that it's 8, times the sum of the 2 bases. We know that one base is 10, and the other base we're calling x. So the sum would be x plus 10. All right, algebra, 72. And 1/2 times 8 is 4. And that is x plus 10. All right, so what we could do now is we could distribute this 4 into that 4x plus 10. 4x plus 40 is equal to 72. And then this can continue to solve for x by subtracting 40 from both sides. And that brings you to 32 on the left and is equal to 4x. And offsetting this multiplication by 4 with an inverse dividing by 4, you get x is 8. Okay, x is equal to 8. So the other base is 8. Example 6. So be on the lookout for those types of problems today. And lastly, today is example 7, find x. All right, so we have this x here, and we know that that is x, and we know that this is 7.3. So we probably should put down that this is 7.3. So we know the area is 96, and that's equal to 1/2 times the product of the 2 diagonals. Well, one side is 7.3 and the other side is 7.3. So one diagonal is 14.6. All right, the other diagonal is x plus x or 2x. Okay, combine your like terms. X plus x is 2x. Okay, so as you work through this problem, you have 96, and let's take care of this little half by multiplying by 2. So we'll do that first. And so with doing that, that cancels, and you have 14.6 times 2x is 29.2. Let me switch back to black here. Is 29.2x is equal to 192. Okay, so if you can use the reciprocal, multiplying by 2 to take out that half, these algebra problems, it's one technique to clean it up. So lastly, divide by 29.2 and divide by 29.2, and you have yourself 6.58 inches is x. And that's example 7. And take a look on the notes today, because on the bottom of the notes, we'll have a nice little concept summary here. It's got the parallelogram, the triangles, the trapezoids, and rhombi and kites, and all of the relationships that we've covered the last couple days. Okay, area, base times the height, and area is 1/2 times base times height, and the trapezoid and the rhombi we covered today. All right, folks, take a look at that as your video today. Hope you found this helpful, and talk with you soon. Take care now, everyone.